Hey everybody, Joe Konkoly in the shop. Today we're going to talk about bridges. I got lots of bridges right here. We're going to talk about them.
I think Joe's doing a video.
Yeah, and so the bridge is a very important part, both structurally and tonally, of an acoustic guitar. We are specifically focusing on steel string flat top guitar bridges today, which you might have noticed is kind of my thing. So let's see. Let's take a look. Yeah, this is my first bridge here. This is a bridge, a vintage bridge made by DJ Thompson, ProLutheryTools.com, and it is for a Martin guitar. I believe this is the 1940s style bridge. So it has a very specific footprint here, which is this shape right here, and it has some structural elements we'll look at. So as that footprint, back in the old days when Martin first started making guitars, they used bridges more like this, which were rectangular in shape. They changed to what is called a belly bridge, probably in the I'm thinking it's the late 30s. Let me see here. I don't really have that one on my little chart here, but anyhow, it's called a belly bridge because of this protrusion on the back edge. And the first thing that protrusion does is to give it a bigger footprint rather than that straight rectangle. It specifically gives it a bigger footprint right here in the area where the bridge pin holes are. These are the bridge pin holes. The strings go down into those holes, and there are pins put in there to secure the string, and that is where there's a lot of tension from the strings right there. And so there's a lot of tension right in that middle area of the bridge, so they extended the belly back or put a belly on the bridge so that there would be a slightly larger footprint, a little more, spread that tension out over a slightly bigger area and allow the bridge to stay down without adding a tremendous amount of mass to it. The other thing that these bridges, a lot of bridges have, is what's called wings right here. Notice in this profile here where there is wood scooped out from there and give it that sort of look like a bird wing. And that is done to reduce the mass of that area there, because the bridge has to be you try to approach that line of minimal mass, but yet enough area so that it will stay structurally intact. Not only stay glued to the top, but also be strong enough to withhold the forward tension of the strings, because the strings are pulling on it in this direction. So there's a lot of torque on the bridge in that way, and the top. So that glue joint between the two is very important. So there's your basic belly bridge. You'll notice that the saddle slot right here, let's see, saddle slot is what's called a through bridge saddle slot. It goes all the way through the wings, as opposed to a closed end slot, which ends before it comes to this line right here where the wing and the main body of the bridge meet right there. So this is a modern closed end slot. This is a long through bridge slot. One of the things that is different about those two slots, in addition to their length, is the depth. This slot can only be so deep, only so deep, so it can't be deeper than the thickness of these wings. It's going to only go down to that point. So let's see. You can see, because of the slope or radius on the top of the bridge, that the slot is shallower on the treble side, deepest in the middle, and again slopes off, or it gets less deep at the. You can see the depth of that slot. So that slot is cut for the most part parallel to the top of the bridge. The top of the bridge is a little bit shorter, meaning in this direction right here, on the treble side, a little bit taller on the bass side. So it has an arch like this, and that arch has a slant to it where it's a little shorter on the treble side. That is to accommodate the ideal string action. The smaller or treble side strings, when they're tuned to pitch, they do not fluctuate as much as the larger bass strings. You can see that when you pluck the string of a guitar. You can hit it and you can watch the string oscillate. And so the bass strings need to be a little bit further away from the frets to play clean, and the treble strings. So that is reflected in the geometry of this bridge. So with a closed slot, I can take the depth of that slot down into the meaty part of here and not worry about there. So I can take it even, right down into there. So let me do a quick measurement here. The depth of this slot in the middle, right between the D and the G strings, is approximately, let's see, around 15/64 of an inch. This one is only about, let's see, 4, 5, about 11/64 of an inch in the middle. So for the most part, that holds up. For most bridges with a closed end slot have a deeper slot, so that saddle has a fair amount of support on either side of it. So that allows us to put the saddle into this slot with no adhesive. We can get a nice tight fit there, and the saddle will have a nice amount of support on either side. With this longer style vintage slot, because it's shallower, most of the time the longer style vintage slots, the saddle is glued in because it does not have enough support on either side to withstand that forward tension of the strings. So that saddle is glued in. And so it's a couple of differences there. Let's look at, let's see, so in addition to all the slots on steel string guitars should have a slight angle towards the bass side. So it is further away from these pinholes on the treble side than it is on the bass side. That is to accommodate for the size of the strings intonation-wise. The thicker the string is, the more compensation it needs to play in tune, compensation being some extra length to it. So that's why we have the slant there. This is a saddle from, it was originally made for the D1 guitar that Martin put out, I think it was in the 80s, maybe the 90s, but it has a couple little innovations or modern touches to it. Because of that slant of the slot, and we talked about how the bass string is closer, or the bass bridge pin is closer to the saddle slot than the treble one is. Notice on this one, the pinholes are parallel to the saddle slot. They are slanted back also. These are parallel to the front edge of the bridge. They go straight across. These move, so we have an equal distance between each bridge pin and the saddle slot. You can see that this bridge already has a string slot cut into it. On the vintage bridge, there are several different types of bridge pins that might go into this vintage bridge, whereas this, there is really one type that goes in. The bridge pins that fit in here occupy a tapered fit hole. The bridge pins have a taper, the hole has a matching taper, and there must be some accommodation made for the string itself. And the evolution of bridge pins and the string slots that couple with them, they started off with bridge pins with no slot cut in them, and the slot that was there to accommodate the strings was cut all into the bridge itself. And that evolved into a bridge pin with a slot cut in it, and that slot was just deep enough for about half of the width of the string, and the other half of that width was accommodated in the bridge. This modern bridge has pins with a deeper slot where that whole slot accommodates the string, and so the slot that is cut in the bridge for these does not need to accommodate the string here on the bottom. It is just, so these slots are cut just to space the string properly and send it forward over the saddle. That brings me to a couple of tools here, because we're talking about bridge pins, holes, and bridge pin slots. Most bridge pins are tapered with two standard tapers, a 3-degree taper and a 5-degree taper. This is my 3-degree tapered reamer. This is my 5. So that when I'm fitting a bridge pin to a bridge hole, I take the reamer, I stick the pin in there, test it, take the reamer in, and remove some wood with the proper taper to the pin fits in properly. Most older pins are 3 degrees, most modern pins are 5 degrees. Once I fit that pin into that point, I then put a slight chamfer on the edge of the hole with this bit. You can see that slight ring around the hole, and that is made by putting this in a drill and cutting that slightly chamfered area there. Then I would create the slot itself. We use these saws. You can see there are two different thicknesses. One thicker for the bass strings, one a little bit narrower for the treble strings. The slot that we're trying to would be creating there is for the double wrapped part of the string, which, if I had a string here, I could show you. It's for the double wrapped part of the string, which is slightly thicker than the string itself. And so first I would cut that slot in there and make it the length that I need to, depending on the style of bridge pin. If it's an unslotted pin, like this right here. Thank you, Steve. See, there's the string that we, just the regular part of the string that we use, and there's the double wrap there. So this is the part that is accommodated in that bridge slot. It sits like that in it. And so first I take and create that slot the correct length, and then I use my set of bridge pin slotting files to customize that slot. I use this then to get the correct width and also the correct shape. You can see this file. This is the only cutting surface on that file, is that front edge. It has a half round surface, and that's where the cutting area is. So I would stick it in the bridge pin and then modify the slot that I've cut with these saws to be the right size for each string. So that way you'd get a very tight fit between the bridge pin and the string and the slot and the hole that are all accommodating that. The nicer, tighter fit you get, the less energy is lost when the energy that you impart to the string travels down the end of the string and into the bridge. The bridge couples it to the top. That starts the top move, and that moves the air in the box. And when it comes out the sound hole, that's, well, that whole combination is what we hear. All right, so there's bridge pins. Most Martin style guitars have had some fairly precise dimensions pretty much forever. They're all about 6 inches long. The modern bridges have a slightly wider wing, which is a little over an inch, say 1 1/16 inches. The vintage ones are right in an inch usually. The belly is also a little bit bigger in this direction on the modern bridges a little bit smaller on the vintage bridges, and just the shape of this curve in the back can be slightly different. On the vintage ones, this is more of a straight line, a little bit more of a curve on the modern ones, and this slopes into this a little more sharper, shall I say, where this line here stays straighter for longer until it curves up into there. On the modern one, that curve starts almost right at the tip here and on out. Just to, some subtle differences. And some other subtle differences are how this curve in the back on the older bridges, this is usually flatter or more severe. There's more material taken from there than on the later bridges where it's very rounded and there's just a little bit more material there. Just some subtleties between vintage bridges and modern bridges. We've got a couple other Martin style bridges here. This is a Martin style bridge with no pinholes and no slot. This can be very useful as a replacement bridge where the bridge you're replacing has the correct footprint, but possibly the slot was cut in the wrong spot. Let's say if the slot, well, for proper intonation, if you need to move the slot back towards the belly, you can do that sometimes by plugging this slot and recutting one a little further back, but you very quickly, there's not a whole lot of room here between the bass E string and the back of the slot, as I mentioned before, so there's only so much room you can move a slot back, and if you needed to move the slot back, you could use one of these bridges where you could cut the slot where you need it and then have the bridge pin holes a little bit further back so that there would not be too sharp of an angle when the low E string comes out of that slot and rides over the saddle. You want to have a pretty good angle there, but too steep and you will put too much forward pressure on the bridge and crack it right here where this, crack the front of the bridge off at the slot. That can happen sometimes. So that's a handy style bridge. This one is another way to accommodate that situation where the intonation is off on the guitar because the saddle slot is too far forward, too close to the neck. It needs to be moved back. This is an oversized bridge. You can see that it takes up a larger footprint than this one. Takes up a larger footprint, and the reason that is so is because it has the saddle slot further away from the front edge of the bridge. It's pretty obvious there. You can see this one is quite close to the front edge. This one is quite a bit further away, and a corresponding set of pinholes that are further back, so the whole bridge is basically larger in this direction. This is another way to correct guitar with improper intonation. You can plug and re-drill the pinholes and then glue this bridge on where the front edge matches the finish line on the guitar, and you would remove some finish on the back edge and basically move the whole thing back towards the back end of the guitar to correct the intonation. The saddleback oversized bridge. Here we have some rectangular bridges. This is what's called a New York style bridge. Basically, it's a rectangular bridge with the same style wings as our belly bridge. And it's called a New Yorker style bridge because the C.F. Martin Company was located in New York when these bridges were used originally, before they moved to Nazareth, PA. But it is essentially that belly bridge without the belly. And still used on a lot of smaller body guitars where with a lighter gauge string and a shorter scale length, the tension on the guitar is not a tremendous amount, or not as much as, say, on a dreadnought guitar with a medium gauge set of strings, and that smaller guitar can deal with this smaller footprint and stay glued to the top securely. But that's a New York style bridge. Here we have two different pyramid bridges, very similar to the New York style bridge, but the wings are completely different. They are carved in a pyramid shape. So there are four fairly distinct facets on that pyramid that are very flat, and this facet has a rounded edge to it and blends into this edge on those two and blends into this curve right there. A couple different style ones. This is a T.J. Thompson 30 style vintage pyramid bridge with a through saddle and a very distinct and carve on the back edge. This one is a more modern style one with that would actually allow you to reshape it into something like this if you need to, or extend the slot if you needed to, but sort of a modern version of this older style bridge with a closed end slot. All right, let's take a look at some other bridges here. Just grabbed a small variety of other style bridges that a lot of the principle is the same, but it's where different companies have used slightly different aesthetics to establish a bridge shape, which can be as distinctive as the peg head shape and really define the design of the guitar. These two, let's see, let's go in this order right here. First we have a couple of reverse belly bridges from Gibson. Actually, this is a real Gibson reverse belly bridge. This is a modern replica or a replacement bridge. So with Gibson, they took and put the belly on the front side rather than the back side. It allowed for this very large saddle slot. So you can see it goes all the way through. This is a saddle slot for an adjustable bridge guitar. On the Gibson adjustable bridge guitars, there would be two studs on the end of this saddle slot that are embedded into the top of the guitar, and those two studs accommodate two adjustable screws that hold an adjustable bridge and allow it to go up and down. So this, and the intonation angle is pretty severe on this. They also have two screw holes at the end of the 6 pinholes. The bridge was glued down and screwed down. You might notice that this bridge has a repaired crack in it. That's why we have it. The whole back end of it cracked off from right there all the way through the pinholes and all the way off. So there are some challenges for a reverse belly bridge of this type. There's a lot of forward tension on it and not a lot of meat back here where the tension is most at the bridge pinholes. So that's one of the problems with a reverse belly bridge, and why you might choose a more modern style bridge to replace that, where you don't have the large high tension adjustable slot there to deal with. But anyhow, replacement reverse belly bridges. These bridges are from Guild Guitars, and they essentially just did some slightly different shapes to make their design a little more distinct. This is an older style Guild bridge where it has the belly, but they added a couple of points here just for mostly for decorative purposes. It could accomplish the idea of a slightly larger footprint than a belly bridge, but it just gives for a nice unique shape. You'll notice that the contour in this direction is pretty much, there is a slope pretty much from the back edge all the way to the front edge, and that slope, you see it there, that slope creates this nice curve right here when we carve the bridge wing out. So that it gives it that nice curve, and it's just a pretty distinctive look. This happens to have a through bridge slot also. This is a slightly more modern Guild bridge where it still has the remnants of that belly with the points there, but they've sort of softened the curves and made it not quite as long, a little shorter, but also a little wider in this direction. So it has a larger footprint in one way, but not as big in the other way. The lines on the top are not as distinct. There is a, you can see it's slightly thicker on the bass side, not much arch to it, slightly thinner on the center side, but they decided to blend this line right here, which is very distinct on a lot of these other bridges, just to give it a softer look on the top. So there's just a variation on the shape of a Guild bridge. The Taylor guitar bridge. Again, these shapes are very much a part of the design of the guitar and iconic. The Taylors have a curve to this front edge, which is a nice look. It kind of mirrors the curve on the back. They made a nice smooth curve where they do not have the belly, it's a larger belly with a bigger curve, and it's like it's one larger curve, but it does curve out this way for a little point on the back edge. But they have the closed slot and the pinholes that are, I guess, 90 degrees to the center line of the bridge rather than slanted with the slot. And the profile on the top is a little different. It's very flat, same size on the treble, bass side as it is on the treble, so that this line in the transition is just a straight line at that curve. Just another variation on that theme. But that's my bridges. Let's see, I think I've gone through all my stuff here. If you remember, this relates to our previous talk on fingerboards, neck angles, string spacing at the bridge, nut width, all those, excuse me, things coming together to each design has to fit with those other parts. And we talked previously about the thickness of the bridge and how that relates to the neck angle. And there you go. Some bridges. And we will continue, if I can think of anything more to do on guitar geometry. I might be out of ideas here soon. But I hope to, in the near future, get back to one of our shop walkthroughs, and I can show you what the guys are working on at their bench. And Stretch and I were talking about some banjo geometry ideas. So that's what we got in store for you in the future. Thanks for tuning in. Share us on Facebook. See you next week.